Siddhas University here. He has done, that's why now many students both in fixed point theory and data sciences and other related many interesting area, and he always motivate the students to do better work. In fact, that's what some 2008 I think. That's one of the student is Dr. Uma. Some group of students, 10 MPhil students, to do their project work, he sent all of them to Chennai, then Madras. So they came to IIT Madras, visited the department, library, and went to other research institute, Madras University, Math Science, and other places at their level. Just they were doing MPhil. That going there and see some of the other people, what type of work, and mainly even to do talk with some research scholars and other students and do some, collect some good papers and then to do some good project. Like that he always motivate the student. So you all know better than me. So it is, we were long time friends, family friends. It is always my pleasure. It is my pleasure to welcome Professor Murthy to deliver this talk. He will be talking on historical results and their consequences after Banach, 1922, Kannan 67 and Jung in 76 and many other interesting results. So I request Professor Murthy to start.
Okay. Thank you, Professor Virumani. Thanks for very nice, affectionate and good introduction, and such introduction from an eminent mathematician like Professor Virumani is really, I am fortunate that he is here and talking about certain things, some issues, some results and motivation, philosophy, all such things. Actually, I intend to speak about that how the things are motivating us to discover some new ideas. That is what my thinking is. And at the school level, whenever any teacher says that mathematics is very hard, I feel very bad about it. That why they say mathematics is very hard and why they are not able to translate that hardship into the very easiest way, or I can say in a conventional manner to convince us. In such a scenario, when it was a chance for me to visit Africa, particularly the East African countries, and there I find that the people says that the hard and easy, what I realize, this is purely my perception, hard or easy, this is all the perception. Of course, the hard things you need little bit more efforts, that's true, and you can make it easy. Sometimes you have to work for a long time to understand such concepts, and loving the particular I can say the person first, because the first person used to deliver the such interesting results, such interesting subjects. So unless you like the person, I also realized for the past 30-35 years of my teaching experience that it is difficult for us to decide whether the subject is hard or easy. There are many subjects, initial stage we feel is not easy, is very hard, and later on we realize that this is really a very easy task to understand. So this is what my journey. I will reflect this talk will reflect the results which I liked mostly. Like the Banach, when we say about the Banach, and I tried to organize one international conference were in a virtual mode in 2022. In 2022, I tried during April-May 2022 and thought to organize the conference before completion of the end of the 2022, and I tried to connect all over the world. 2-3 meetings were also done. Few people promised, and sometimes I find that something happened that I presumed the promises may work and promises doesn't work, and finally I failed to organize such a big conference for a giant of this functional analysis. We call it as a Banach. So let us start with what exactly the philosophy can be. Like Professor Vasil Virende, as he said about the Banach, few things I was also not knowing, few people he may not be knowing. This is possible because we interact with the people and we may not know many things. So when you look into the Brouwer's fixed point theorem, there are actually the result even before the Brouwer also. Historical fixed point theory is there, but later on they realize that what they are talking about, the solution is nothing but a fixed point. So Brouwer's fixed point theorem. So in Brouwer fixed point theorem, you know very well that it's a very simple and elegant proof, one line statement. So when you look the Brouwer's fixed point theorem, you will realize that the continuity on a closed interval is must, and then it promises that the continuous function is having a fixed point. It's not giving any guarantee to have a unique fixed point, and those days I think they might have now thought about that whether we should look on the uniqueness of the fixed point or not. So Brouwer has done, and after the Brouwer also, Brouwer did a lot of work, and as we today call it as a topological fixed points. Before the Brouwer, we have the Lipschitz condition also, and the Lipschitz condition, if I can write in the real line, then I can write in this manner: Tx minus Ty is less than or equals to L times of mod of x minus y, and this L is greater than or equals to 0, and x can be in x and y can be in x. Right? This one, if I say in view of the Brouwer, then T is continuous. So what are the main features in Brouwer? The first is the function is a continuous function. The second thing is closed interval, and we know very well that closed interval of R is a complete metric space. So is complete. So we have a result that every closed subset of a complete metric space is also complete. So another way I can say that they have the complete space. So F, then completeness, continuity, completeness, and they have the fixed point. Okay. Then Lipschitz is having this, that L is greater than or equal to 0, and if I say same thing, translate in view of Banach, then I will say that this L is less than 1. So we have to understand why L is less than 1. So when you involve in the deep research and you try to do certain things, I think this is the human brain, they get the intuitions, that's true. Whether your result is going to be true or false or maybe in between. You get intuitions, that's true, we get intuitions. Many quarters we can understand that this hypothesis may have some result. Maybe in fixed point theory what we are talking about is some sort of concrete type of. Let me take some examples of Brouwer's fixed point theorem. Yeah, this is the example one I was talking about earlier also. When you look into this, the function is continuous and you can see that by applying the intermediate theorem, so intermediate value theorem, you have a fixed point. So we are not talking about any uniqueness of the fixed point, the function is continuous, completeness property is also there and you have the fixed point, right. So means is satisfying the hypothesis of Brouwer's fixed point theorem. Let us go for the next example. See this example. Our space is not closed, okay, is a semi. The function, you can see the function is a continuous function, it's a continuous function, okay. But when you realize that whether the function is having a fixed point or not, continuity is there, but the function is not providing us the fixed point. Other conditions I mentioned, some additional conditions, that whether the space is connected or compact or whatever it may be. If I am getting some additional features also, I used to write. So the space is not a closed interval, so even the function is continuous, we do not have the fixed point. Let us go to the next example. These are I am carrying for the past 20-25 years. Check the next one. Space is closed, closed interval is there, the function is defined, okay. So whether function is continuous or not, the function is actually split at the point half, okay. So what do you say about the continuity? I mentioned fine, but you have to know whether the function is continuous or not, you have to verify that. So function is discontinuous function, is not a continuous function. So one hypothesis satisfied, the second hypothesis not satisfying. So definitely suppose not to reach to the destination means should not have the fixed point. So not having the fixed point. Let us go to the next example. This is the example 4. Now look at this example. Both are closed, okay. I am making the union of these two closed intervals, and the function is a constant function. Every constant function is a continuous function. So is continuous. You have the Heinbold theorem for the compactness. Every closed and bounded subset of R is compact. So F is continuous, Y is not compact, you should know. Y is not compact. Draw on a real line and you try to understand that what is the gap actually. Why these two closed intervals are not compact. Any union of closed interval is compact. This is a question. So here you will find that is not compact, and later on I mention that connected also. So do this function have a fixed point? Yes.
When we discuss about fixed point,
So that
we usually work on self-map. I don't think it is a self-map.
which one? Function? Yeah. What is the gap actually here?
So, I'm talking about self-map.
No, that you are talking about the self map always for fixed points, not necessary. You can have a metric space X with any metric, you have another metric space Y with any metric, you can have the fixed point.
Sir, we are talking about usual normalization.
Normally you write always X to X, but it's not necessary. There are many results available, but may not be working on that, you people, but it is there. There are good number of results.
At least the domain and codomain must have a point improvement. Domain and codomain
Yeah.
must have intersection, no
Intersection is non-empty. Here what happened? Intersection is empty. Okay. So do they have the fixed point? How they can? Okay. So they don't have the fixed point. Let us see the, so what happened here? So I say that is sufficient but not necessary. Okay. So the next example you see. Here is also the same kind. You can say what you are asking the question. Now check here.
So it is self.
Here they see your X is 0 to 1/3, 2/3 to infinity. Again 1/3 to 2/3. That part is not there. That part is not there. 1/3 to close interval 1/3, 2/3 is not there, right? Clear? Now you see the function. So X is not closed. See here, is not bounded also, is not connected also, is not continuous also. All whatever the hypothesis you need, none of the hypothesis is satisfying here. But what about the fixed point? It has a fixed point. It has a fixed point. Okay? Means maybe there are some results we are not even involved in such results. Like yesterday somebody is asking professor about the, I don't know whether this professor or someone else, so about the fixed points of the discontinuous maps. There are proofs, already proofs are available that if the function is discontinuous, it may have the fixed point. That is also possible. Okay. The Banach contraction condition has the beauty. So see here. So means
Maybe some typo.
where?
Infinity closed.
Yeah, it is typo error. Infinity can't be closed. Yeah, open is open.
The set will be closed.
Yeah. No, infinity is open. It should typographical error. Typographical error. So I did not check actually so seriously this part. I closed that one because we use LaTeX. So that's why, that may be the reason. So see this one. So what exactly we are trying to draw from this, that this is Banach, this is Lipschitz. Okay, and what exactly the Banach has done in the Lipschitz, we have to assume the function is continuous, and what the Banach has done, he is deriving the continuity from the contraction itself, the condition or inequality itself. That is the beauty. So means we are not actually putting condition on the function, that function is supposed to be continuous. You are deriving the continuity from the condition itself. This is what the Banach contraction condition speaks about. The other thing is, what is the actually the utility of this condition? Is it necessary that unless we assume this contraction condition, then only we proceed for the proof? Where exactly the Banach has a problem? Because using the Picard's iteration. Lot of people since for the past 3 days the same thing is going on, so you are well versed with the iteration schemes, particularly the Picard's, which is a initial of the iteration scheme. So the issue comes when you are trying to prove the convergence part. Even for the Cauchy, what about the Cauchy? So we have to think whether this condition can be removed or not. Your theorems should be in such a manner that if one of the assumption is removed, the theorem should fail. I am saying particularly whenever we write any result. Always I give the example of the Pythagoras theorem. Best example in mathematics is the Pythagoras theorem. If you say right angle triangle satisfying this condition, if satisfying this condition, right angle triangle. If you remove one of the condition, not satisfying. That's the beauty, the minimal conditions. And now these days what happen? Sometimes we don't care about the number of conditions putting on the theorem. Of course, Banach fixed point theorem, in the Banach you will find the strong assumptions, no doubt about it, for getting what? Uniqueness of the fixed point. For the uniqueness of, if I say fixed point and all fixed points are, if I somewhat I say okay fixed point, I got the fixed point, because my destination is a fixed point, whether you are trying to obtain either topological or analytical or analysis through analysis, whatever it may be, I have a fixed point. But ultimately doing this much exercise, the heavy exercise, because of uniqueness, right? This is what. So now actually the last result motivated me to saying that sometimes it's possible that none of the features or circumstances favor us, but even though we are strong enough to face the situation to achieve our goal. This is the realistic, and sometimes we have to learn such realistic situations of some contrary examples. This could be one of the example that all the situations are against, even though they succeeded in getting the result. This I will talk about little bit later. So my main intention is, after this, see, this is the result of 1922, and after 1922 you know very well that in the world scenario there are so many things happen, not only in the context of our country but in the context of the world. We have 2 world wars in between. So the development of the mathematics, development of science and technology, development of many things, the operation research established during this time mainly between the world wars, because it was a need actually, optimization, okay. So by Banach, Lipschitz, and when you go little bit ahead, these are all the iterations, and people are working on the iteration side also, lot of iterations are there, and Professor Birende, he was talking about the iterations a lot, in particularly he is working, so I am not going into the depth of all such iterations like Picard's iteration, Mann iteration, Ishikawa iteration, Hong Kong Zoo slightly modified the Picard's iteration scheme, okay, and after that you can find that there are good number of iterations. Now these days when I count, I think definitely 10-15 iterations people so far defined. So, not in that context. Yeah. After Banach, I found most interesting part is like we derived the concept of continuity from the inequality of the Banach itself. So naturally, this is the phenomenal and natural question among the analyst mathematicians, that can we go little bit deviate this continuity part, and you can see that this is the result. R. Kannan, actually he is a student of Calcutta University, joined initially MSc in physics. Why he discontinued, I don't know. Actually, I used to visit Calcutta University very frequently earlier, and he is a student of Professor B.K. Lahiri from Kalyan University. So since I had some interaction earlier, so I came to know that he discontinued physics and joined mathematics, and then the C. Yeah, he is R. Kannan, Tamilian. Okay, so his first result actually published in Bulletin of Calcutta Mathematical Society. I am referring the 1969 result published in Proceedings, but published originally in Bulletin of Calcutta Mathematical Society. So sometimes now in today's scenario, when you look into the even the general sections, right? So because of you only, because of your results only, generals are famous. And now these days what we do? Because generals are famous, let us send the paper to such generals. Because of general, I can also be famous. If my name is XYZ, my result is very good, I have doubt on my own result, and because of the doubt, I feel that which is the best general in the world. I am searching such general and submitting my paper for publication to such generals. So see the scenario. The man who published his result in our own Indian journal, and see the result in the world level. Same Banach also, that result is a part of his PhD thesis. How many of us are there that our PhD thesis is so strong, then that gets this much citations? Lecture is fine, but definitely I want to motivate you people that do something and is in you. You don't underestimate. Definitely you can do it. And out of these 24 hours, at least 1 hour, means 23 hours may not be working for you, but 1 hour out of 24 hours definitely working for you. Only you have to identify that 1 hour. That 1 hour falls in which period, that you have to identify. If you can identify, you continue with that hour, then you are also different. But once again, same thing, like finding the best journal in the world and trying to submit our paper into that journal. Same, we are trying to find out the time which is convenient to me, not I am convenient to the time. See the result, so just a function is different. Now we are talking about the inverse function. This is what. So this is also one of the, I can say that most liking condition, inequality for me. And Professor B.K. Lahiri suggested me those days. I did my PhD in 1992, and these stalwarts were my PhD examiners. I think with Professor we have the first interaction in 1989, I think, 88, 89. Since then, whenever